Hello, I'm Krista Wilson, and in this video I'll be discussing our paper, Building and Auditing Fair Algorithms, a case study in candidate screening. This is joint work with my students and colleagues at Northeastern University and our collaborators at Pymetrics. Today there is widespread recognition that machine learning applications can go horribly awry in practice, resulting in a range of serious problems such as unjustified bias, unfairness, and injustice. I believe that algorithm auditing is a critical part of the solution to these problems. The high-level idea behind an algorithm audit is that a socio-technical system and its data is critically examined by experts, ideally independent experts. Algorithm audits help foster transparency and increase accountability by making it much harder to hide problematic systems. While researchers and even regulators have begun to show interest in the practice of algorithm auditing, there is still a significant amount of uncertainty around this practice. The vast majority of existing audits in the literature are permissionless. These are black box tests conducted by outsiders without the permission of the algorithm owner. While permissionless audits have been very successful, there is a need to develop approaches and methods for permissioned audits. In other words, how can outside experts and system owners cooperate to conduct audits? This is where Pymetrics enters the story. Pymetrics is a startup that offers a pre-employment assessment service. In brief, job seekers play games that purport to assess their intrinsic qualities. Machine learning models use the gameplay data to predict whether job seekers are a good fit for a variety of jobs, and that employers are free to interview these candidates. Crucially, Pymetrics claims that their models are fair, and I'll explain exactly what they mean by that a little bit later. In October of 2019, Pymetrics approached us about the possibility of auditing their candidate screening tool. In my opinion, Pymetrics is an ideal candidate for an audit for two reasons. First, they operate in a heavily regulated and heavily scrutinized area. Given the high stakes of the employment context, it is crucial that systems like this be scrutinized. Second, Pymetrics has made strong public claims about the fairness of their tools, but prior to our audit, these claims had never been independently validated. Although Pymetrics has open sourced some of their fairness testing framework, by itself, this is not enough. From our perspective as auditors, we were really intrigued by Pymetrics' proposition. We were excited not just by the opportunity to audit Pymetrics specifically, but also to establish a model for outside experts to collaborate with a company on an audit. Prior to this project, we had never conducted an audit with a willing company, and there were no examples of this occurring in the public domain. So this brings me to the goals and contributions of this project. First, we make some specific technical contributions. We describe in detail how Pymetrics implements adverse impact testing in their candidate screening tool to achieve fairness. We document the process we used for our audit to make it reusable in the future, and we present the specific results of this audit. Second, we hope this project will have broader impacts. This is, to the best of our knowledge, one of only two publicly documented algorithm audits where a company willingly had an outside expert scrutinize their systems. We refer to this mode of investigation as a cooperative audit. By successfully completing this audit and demonstrating that this style of work is feasible, we hope to encourage other companies to engage with auditors and provide a playbook for this style of cooperative auditing. So here's the outline for the rest of the talk. I'll start by briefly discussing how Pymetrics' candidate screening tool works and how they implement fairness testing. Next, I'll talk about the design of our audit and the challenges we faced. I'll talk about the specific results of this audit, and finally, I'll conclude with lessons learned and broad takeaways. So let's start with Pymetrics. As I already mentioned, Pymetrics' primary product is a machine learning-powered candidate screening service for employers. The underlying basis for the candidate screening tool is gamified psychological assessments. In layman's terms, candidates for jobs play games. Their performance in the games is measured, and then this data is used to assess their fit for specific jobs. At a high level, I'll walk you through how Pymetrics' tool works. First, a client company contracts with Pymetrics and says they would like to recruit people for some specific job. The client then provides two data sets to Pymetrics about incumbent employees that are already in that job. One is performance data about these employees. This might come from qualitative assessments like yearly reviews or quantitative data like monthly sales. Second, the client has incumbent employees play the Pymetrics suite of games. Next, Pymetrics trains machine learning models to try to predict who will succeed at this specific job. The model takes training data from two data sets as input. The first data sets are those that were produced by the client in the previous step. The second data set that Pymetrics uses to train the models is randomly sampled past gameplay data from other candidates. So these are used as the negative training examples. Now, it's important to note at this point, during model training, Pymetrics claims that no demographic information about candidates is used. And this is a claim that we'll come back to later in our audit. Next, Pymetrics performs adverse impact testing on the trained models. The goal is to identify models that comply with the 4/5 rule with respect to binary gender categories and a set of 5 racial and ethnic categories. This testing is conducted using a held-out set of gameplay data from candidates with known demographics. So Pymetrics is essentially asking, if these held-out candidates applied for this job, would the output of the model exhibit demographic parity in line with the 4/5 rule? This process of model training and adverse impact testing is iterative. Pymetrics' system is searching for a model with the greatest predictive performance that is also fair according to the 4/5 rule. Assuming that such a model can be found, it is deployed into production. So candidates who apply for this job will play the Pymetrics games, the model will predict whether they're a good fit for this job, and the employer is then free to interview them. Note that during this process, Pymetrics asks candidates to complete an optional demographic survey. So this data that Pymetrics collects from job seekers in this last step is used to build and evaluate future models. So some of this data can be used as negative training samples for future model training. Other data that includes self-identified demographics can then also be used for adverse impact testing of future models. So for our purposes, the most important part of this process is here, the adverse impact testing. This is going to be the focus of our audit. Now let's move on to talking about the design of our audit. As I mentioned earlier, despite having conducted many algorithm audits in the past, we have never conducted one quite like this before. Furthermore, nobody else had either, so we had very little examples to go on. So before we agreed to conduct this audit, we spent a lot of time thinking about the major challenges we would face and devising strategies to try and mitigate them. The first major challenge was establishing the scope of our audit. What were we going to test, and what would be the baselines for comparison? And just as important, what were we not going to test? The second major challenge was maintaining the credibility of our audit. Our past algorithm audits have all been permissionless. The company didn't know they were being audited, and thus we were completely independent. But this audit would be different. We would be given privileged access and resources, which raises a whole host of concerns about maintaining our independence and an arm's length relationship with Pymetrics. With respect to scoping our audit, we settled on 5 specific technical aspects of Pymetrics' candidate screening tool to evaluate. So this includes whether Pymetrics' implementation of the 4/5 rule was correct and bug-free, whether their models exhibited direct discrimination by directly using demographic data as features, whether Pymetrics had robust socio-technical safeguards to prevent human error from compromising fairness guarantees, whether there was potential for a malicious client to try and intentionally circumvent Pymetrics' fairness guarantees, and lastly, were there any assumptions baked into Pymetrics' data cleaning process that might cause the models to be subtly biased? Just as important as what we did test is what we decided not to test. So we agreed with Pymetrics upfront that we would not evaluate alternative fairness metrics. We would stick to the 4/5 rule. So Pymetrics has done extensive legal analysis, and they've come to the conclusion their approach to adverse impact testing will stand up to legal scrutiny. We are not lawyers, so we saw no reason to second-guess their expertise in this regard. We did not evaluate the predictive validity of Pymetrics' gamified assessments. Simply put, we are not cognitive scientists or employment assessment experts, and thus we're not qualified to audit the validity of the Pymetrics games. We only audited Pymetrics' candidate screening tool, not other products. And lastly, this was a fairness compliance audit. We didn't examine anything related to cybersecurity or privacy. So with respect to maintaining the credibility of this audit, we made a number of critical decisions. So yes, we were paid to conduct this audit. After extensive deliberation, we decided to accept payment in the form of a grant to Northeastern University. This payment was delivered before the completion of the audit and was not contingent upon results. We felt that this arrangement offered us sufficient protection for our autonomy, while still fairly compensating us and our PhD students for our time and expertise. We implemented extensive secrecy protocols before we began this audit. To the greatest extent possible, we did not reveal how we planned to test the Pymetrics system or even the specific tests we planned to run ahead of time. When we communicated with Pymetrics staff, we kept our questions general and ambiguous. Crucially, the contract for the audit stipulated that we retained full rights to talk and write about the audit and its results, whether they were positive or negative. The only exceptions to this were related to source code, private datasets, and specific narrow technical details about Pymetrics' intellectual property. To be ethical, we suggested that the contract contain a 30-day responsible disclosure period in the event that we found a serious problem in Pymetrics' systems. So this is a standard practice that we adopted from the cybersecurity community. To further enhance the credibility of our audit, we have adopted a position of radical transparency. The contracts, legal agreements, and budget between Northeastern and Pymetrics are publicly available at my website, and they're also linked in the paper. The paper and the results of the audit are obviously public. And then with respect to the questions about the authorship of this paper, section 3 was written in large part by our collaborators at Pymetrics. This is the section that discusses the technical implementation of their tool. Pymetrics also contributed to section 6, some of the conclusions, but everything else was written by us, in particular, me. So now let's dive into the results of the audit. Recall that we aimed to test 5 specific aspects of Pymetrics' candidate screening tool. The first is correctness. Under normal circumstances, is Pymetrics' implementation of the 4/5 rule correct? Does their tool's behavior match their public claims about its behavior? To answer this, we manually examined their source code and tested it. What we found is that it does indeed operate as claimed. It faithfully implements the 4/5 rule with respect to 7 demographic categories. Our second question, does the Pymetrics tool exhibit direct discrimination? So we found that it does not. Demographic data is used for adverse impact testing, but it is never used as an input feature to the models. Our third question concerned socio-technical safeguards. Is there a possibility for human error to result in the deployment of an unfair model? So we found that Pymetrics has a robust process in place to prevent this. The data scientist who builds a given model has to complete an extensive manual checklist to document their decisions and double-check all critical model attributes. And then a second data scientist has to manually review the model and the checklist before the model can go into production. Our fourth question, could a malicious client use data poisoning approaches to circumvent Pymetrics' adverse impact testing process? To understand whether this was possible, we performed attacks ourselves. So we assume the following threat model, where there's a malicious company that would like to get Pymetrics to train and unwittingly deploy an unfair model. To do this, the company could supply poisoned training data, either in the form of false employee performance data or maliciously crafted gameplay data. So we tried a number of approaches to try and get Pymetrics' system to produce an unfair model. So we tried supplying data that was intentionally biased, say a group of all white men. We tried cloning a single person's gameplay data multiple times and supplying that as training data. We tried taking a single person's gameplay data and then perturbing it slightly to create more variance. But ultimately, all these attacks were failures. So in some cases, the Pymetrics tool failed to find a fair model, and thus the whole process was aborted. In other cases, the tool did actually manage to train a fair model, despite the intentionally biased input data. So either way, the attack is unsuccessful. Our final question concerns sound assumptions. Were there decisions baked into Pymetrics' data cleaning process that could introduce bias into models? For this aspect of the audit, we mainly focused on Pymetrics' use of imputation. So imputation is a standard technique used in most machine learning pipelines to fill in missing data points. In Pymetrics' case, these missing data points can arise when a candidate abandons a game midway or only plays a subset of the available games. So on one hand, we found that the choice of imputation algorithm might have an impact on fairness. So we analyzed a lot of raw data from Pymetrics, and we found that there were statistically significant correlations between the distributions of missing traits, the distributions of gameplay data, and demographics. These correlations suggest that some demographic groups require more imputation overall, and that the feature values selected by the imputer might need to vary by demographic group. On the other hand, when we tested out different imputation algorithms with Pymetrics' model training pipeline, we found that the choice of imputer did not have a substantive impact. So what this plot is showing is fairness evaluation of 7 different models, each of which was evaluated using data imputed using a different imputation algorithm. What we see is that the performance of the models is more or less invariant, regardless of the imputation algorithm that we chose. So in other words, this is a classic case where we observe statistically significant correlations, but the effect sizes are so small as to have a negligible impact on practice. Overall, we see that the Pymetrics candidate assessment tool passed all 5 of the tests in our audit. So to briefly conclude, with regards to specific outcomes, I can say that Pymetrics passed our audit. Additionally, Pymetrics made 2 changes to their tools to improve it in response to our findings. As I'm sure many of you know, ours is no longer the only public cooperative audit. Another hiring startup called HireVue also released an audit conducted by Kathy O'Neill just a few weeks ago. So our audit and the Orca audit are a fascinating study in contrasts. We focused almost exclusively on technical aspects of Pymetrics' system. In contrast, the Orca audit of HireVue focused mostly on stakeholder mapping. They interviewed customers of HireVue and job seekers and activists to understand their concerns about HireVue's systems. However, the Orca auditors didn't do any technical analysis of their own. They relied on self-reports from HireVue, which, in my opinion, is not ideal. Now, you could argue that neither audit went far enough because neither evaluated the end-to-end predictive validity of the tools, and this is a reasonable criticism. That said, both audits did lead to positive changes in the respective companies' tools. So in the future, what I would hope to see are audits that combine the technical rigor of our audit of Pymetrics with the broader ethnographic aspects of the Orca audit of HireVue. Overall, the thing that makes me most proud about this project was that it helps establish a new baseline for what a cooperative algorithm audit can be. So prior work has extensively demonstrated that permissionless black box style audits are possible. I firmly believe that these kinds of audits can and should continue in the future, since there will always be companies that resist voluntary transparency efforts. Right, on the other end of the spectrum, Raji et al. Had a very nice paper in FATSTAR 2020 defining a framework for internal algorithm auditing, right, that a company can use in tandem with the development of their own systems. And this is something that I think all companies should do. Our work in this project falls between these 2 endpoints. So whether it be voluntary or mandated due to regulation, I think companies can and should engage with external experts to audit their algorithms. This is common practice in cybersecurity, and I firmly believe it has to become common practice with regards to fairness and justice work. It's not uncommon to hear companies dismiss algorithm audits as being infeasible, but I think we've clearly shown that this is not the case. By working together and clearly scoping the bounds of an audit, the concerns of outside experts and company insiders can be bridged. So we hope that our work provides a model for more cooperative audits in the future. Thank you very much for your attention and enjoy the rest of the conference.